Good afternoon, everyone. We'll wait for 2 more minutes for the participants to join in and then we'll begin. Good afternoon, everyone, and a very warm welcome to all the participants, dignitaries, and respected resource persons on the second day of our FDP program. We are delighted to see your active participation. Like yesterday, today we are having two insightful sessions lined up for you, and I am certain that will add immense value to our academic and research pursuits. Moving ahead, our first distinguished speaker for the day is Dr. Nilendra Badal. Sir, are you here with us?
Yes, I am here with you.
Welcome, sir. I'd like to take a moment to introduce Sir Dr. Nirendra Badal, Director, Rajkiya Engineering College, Bijnor, Uttar Pradesh. Dr. Badal is a professor in the Department of Computer Science and Engineering at KNIT Sultanpur. He has completed his PhD in Computer Science from MNIT Allahabad, Uttar Pradesh. With more than 16 years of teaching and research experience, he has published over 100 research articles and continues to inspire both students and faculty through his academic leadership. We welcome you to our program, sir. Today, sir will be delivering insights on the topic of role of mathematics in data analysis. I now invite you to deliver your session, sir.
The screen is visible to all of you. Hello. Is this
Yes,
screen
sir.
is visible to all of you?
Yes, sir, you are audible.
Yes.
And screen is visible?
Yes, sir, your
Visible,
screen
sir,
is
visible.
visible to us.
Okay. Thank you. So first of all, welcome to all of you. And the topic on which we want to make a discussion is role of mathematics in data analytics. And I hope all the members from mathematics field and computer science field. So this is the talk flow of my presentation, that is introduction, then foundation, then development of life cycle of data analytics, then mathematical techniques that are involved in data analytics, then cleaning and pre-processing of data analysis, then future and conclusion for the above mentioned subject. So before starting the main theme, that is data analytics and mathematics, my basic question with all of you, that is how can we differentiate data analysis and data analytics? I mean, how can we differentiate analysis and analytics? Anyone who can give the answer of for the analysis and analytics? Analysis is basically concerned what has happened in the past, and on the basis of analytics, that is super domain, including the analysis that provide the answer of the future forthcoming events as well as the previous historical things which has already happened. So data analytics is the process of examine the raw data. It's mean how can we previous existing data we can examine, design the models, make the prediction, draw the conclusion, and drive decision making information. That is the, in a nutshell, that is data analytics. Typically, it involves collection of data, transforming the data, and organizing data sets. It's means first of all collection, transforming to the exact theme and location for the data set, and organization of that data set to identify patterns, correlation, and insights for enhancement of effectiveness and efficiency of the data analytics. That is a theme included in the data analytics. And mathematics, so all of you are very much expert for the field of mathematics. So mathematics is the providing the tools and framework for the field of data analytics for understanding, modeling, interpreting, and presenting the data. That is, first thing is understanding, modeling, interpreting, and presenting. These themes are concerned with the data analytics. With the help of mathematics, we have to execute all these things. So mathematics enables data scientists, in which themes mathematics provide the powers for the data scientists, develop algorithm,
Excuse me, sir.
build. Are you getting my voice or not?
Sir, sorry to interrupt, sir, but your PPT is not visible to us. We can see your desktop, but not your PPT.
Okay. Now PPTs.
No, sir, not yet.
शुरुआत में थी ना प्रेजेंटेबल,
Yes, sir.
तो just because of
We can see it now. Sir, can you make it full screen?
is this visible?
Yes, sir, it is visible. Thank you, sir.
So that was network glitch, I think. So
It can be, sir. It's all right, sir.
it's okay. Now its flow is clear. So mathematics plays an important role in data analytics. इसके पहले स्क्रीन हम इसको फिर से देखना चाहेंगे. Mathematics enables data scientists to develop algorithm, build predictive models, and meaningful information from complex data set. It means mathematics plays an important role in data analytics, in acceleration in process, achieving the prototype. We have taken into consideration prototype model of data analytics. or reach to the final system in less time. So another foundation for data analytics, what type of various type of data analytics are available? Basically, four type of data analytics are available. First is the descriptive analytics, diagnostic analytics, predictive analytics, and perspective and prescriptive analytics. Descriptive analysis and diagnostic analysis, for the some moment, these are related to the analysis also. These descriptive focuses on the summarizing the historical data to understand what has already happened. And diagnostic analysis diagnostic analysis building upon descriptive analytics. Diagnostic analysis explore why something happened. It means for the past execution, this provide the answer what is happened and why it is happened. For the analytics purpose, previous these two themes are important. Then on the basis of this predictive analytics, these types uses statistical modeling and machine learning techniques to forecast future outcome based on historical data. And prescriptive analytics goes a step further by not only predicting outcome but also recommending optimal action to achieve desired result. Overall, types of data analytics concerned with what is happening, why it is happened, and provide the answer what will happen and how and in what manner it can be optimized. So data analytics for any domain, these four types of data analytics concepts are available. For an instance, the characteristic feature advantages and disadvantages. For the mathematical data analytical prototyping, we have identify primary level, medium level, and top level. So those candidates who are on the primary level, they can represent this is characteristic of mathematics and data analytics just for representation. But another characteristic, it provides the precision. At the higher level, a top level provide the functionality and performance and improvisation. So these are the characteristics of the mathematical analytics prototyping and features that is concerned with the flexible, efficient, reliable, and basic advantages of using the mathematical prototype data analytics is improve the understanding and this detection of errors and missing the functionality. It is the basic advantage. You can examine, identify the what functionality is missing, but disadvantages also exist. Sometimes basic linear disadvantages like this improve the complexity of the system or complexity of the prototyping system. This is the, if we are using the higher order of mathematics, then this is very complex to analyze and this. So these in a single statement, we can identify the characteristic feature, advantages and disadvantages of mathematical data analytics. These are the basics. Now, I'm not focusing much more on this thing, data analytics, project management. The theme is concerned with the idea analysis, then build the basic concept, then design the concept, then execute the and realization, then testing and launch. This is the flow for the project tasks which are included in the mathematical type of prototyping of data analytics. But it is very much clear to all of us. This is not a single step process. This is a continuous process. When evolution is done, then again we have to find out the missing, we have to find out the gap, and again we have to introduce the another step for the theme. Now, we are up to this moment, this should be clear what is data analytics and what is mathematics. All of you are expert of mathematics. So it is some of the candidates are experts of mathematics and some of the candidates are experts of computer science. So here we are trying to create a bridge or create a solution for combined approach. How can mathematics scientists or data scientists help each other? So basic structure or basic life cycle of data analytics. First is there exists main theme is the discovery, design, modeling, and execution. But we have described in several steps. First is the discovery and defining the problem and discovery of data collection. So this is the first case which is concerned with the discovery. Then second is concerned these two steps, data analysis and preparation. Third, these three steps is concerned the model planning and building. Then result communication, deployment, and then maintenance. These are the sequence of life cycle of data analytics. So first of all, concerned with the data collection. Then another is the concern of the analysis and pre-processing, preparation, then model building, then execution, and this is the flow of life cycle, or we can say this is the life cycle phases of data analytics. So role of mathematical data analytics prototype. First is that this provide the what are the various opportunity available, what type of strategy we can apply, what can how can we refine the process, how can we estimate the effort, cost, and accuracy, decision journey, organizational utility testing, and all these all type of features may introduce with the help of mathematical data analytical model. So in a broad sense, we can say analytics here. Mathematics is this domain where statistics, optimization, algebra, statistical research are exist. These are the computer science domain, and these are the business domain and domain expert. This may be agriculture, this may be hospital, this may any type of domain. So manual data collection, expert insight, and suggested action, these are the included. And this domain is known as a analytics. This provide the forecast, this provide the data pre-processing, machine learning, with the help of computer science algorithm, with the help of mathematics, with the help of concerned domain, a complete analytics structure may be designed. So this is the discipline related to data analytics, or you can say this is the combinational approach of mathematics. This is the combination of with approach of the computer science. This is the combinational approach of the concerned domain. This may be agriculture. This may be anything. Now, I'm trying to build a concept with reference to mathematical concept which are concerned with specifically concerned with the data analytics. So basic mathematical concept is for the first step mathematical, these fundamental includes arithmetic operation, algebra, and geometry, which serve as the building block for more advanced topic. Understanding these concepts is crucial for performing accurate calculation and developing analytical models. So this is the basic mathematical which we use generally. Arithmetic operations such as addition, subtraction, multiplication, and division are the simplest, at most essential tool in data analytics. They enable analysts to perform basic data manipulation, computing averaging, different type of computation may be performed, different type of aggregation of data points may be executed. On the algebra, provide the language for expressing relationship between variables, solving equation and modeling data. And geometry help in the visualization data through plots and graphs, making it easier to identify patterns and trends. So this is we have taken into consider simplest themes of mathematical concept. This is arithmetic operation, algebra, boolean, the other different type of algebra, geometry themes are available. So at this moment, this first is the concept. This is concerned with the computation, and there is the expression of the relationship. Third is the representation of the data. Now, because all of you very much experts of mathematics, so now we are considering different field of mathematics like statistics, dynamics, and different themes, and how they help or perform the data, support the data analytics. So statistics in data analytics, by providing methods to collect, organize, analyze, and interpret data. It helps in summarizing large data set into meaningful matrices such as mean, median, and standard deviation. Furthermore, inferential test, हम लोग generally we make a discussion on descriptive statistics and inferential statistics. Descriptive statistics measure central tendencies, measures of variability, while inferential statistics making prediction, hypothesis testing, and confidence intervals, these are concerned with the inferential statistics. It's mean by applying statistical method, data analyst can transform raw data into actionable insights, guiding decision-making process in various fields. So this is the simplest theme which we have taken into consideration, that is statistics. Various methods of statistics used in the data analytics, like regression and different themes are available. One by one, we will make a discussion on this. So statistics plays very important role in data analytics because representation of data, raw data, and transforming the raw data into the meaningful data just with the help of statistics. So statistics is the one very important thing. Then probability theory in data analytics. So now I think it should be clear to all of you in which way we are making the discussion. We are taking the different field of mathematics, then making the discussion with a reference to data analytics. First of all, we have taken into simple calculation for data analytics. Then we have the discussion statistics for data analytics. Then probability theory in data analytics. It is very clear to all of us what is probability, what is the role of probability. Probability theory is the mathematical framework for quantifying uncertainty and randomness. I think this is clear to all of us. And then basic concept include event, outcome, and probabilities. The fundamental rule of probability, the addition rule, helps finding the probability of the union, and the multiplication rule is used for the intersection of events. So probability distribution function like normal distribution, binomial distribution, gamma distribution, Poisson distribution are used to model various types of data. These distributions provide insight into the likelihood of different outcomes, helping analysts make informed predictions. In machine learning, probabilistic models such as naive-Bayes classifiers and hidden Markov models are widely used for classification and sequence analysis. Thus, probability theory is a main theme, or the basic theme for data analysis and enabling analysts to handle uncertainty and make data-driven decisions. So this is the basic role of probability theory in the data analytics, is provide the certain outcomes, and on which outcome is favorable for us, it may be decided with the help of probability theory in use of probability theory in the data analytics. So one who are expert of probability theory, they can support data analytics in this way. Another theme of mathematics, or another domain or another subdomain of the mathematics, is linear algebra. This is the backbone of data analytics. Linear algebra is a fundamental in data analysis, providing tools for handling and manipulating high-dimensional data. Single-dimensional data, two-dimensional data, three-dimensional data, and multi-dimensional data may be handled with the help of only linear algebra. Vector and matrices are the primary structure in linear algebra. A vector is an ordered list of numbers representing a point in multidimensional space. Matrices, on the other hand, are rectangular array of numbers used to represent and manipulate linear transformation. I think this is very much clear to all of you. Linear algebra plays a very important role for data analytics, because with the help of linear algebra, we can find out the dependency of with the form of equation as well as another form. So in data analytics, vector and matrices are used to store and process data efficiently. Operations such as matrix multiplication, transposition, and inversion are essential for performing linear transformation, solving system of linear equation, and developing algorithm. These operation enables analysts to work with large data sets, perform dimensionality reduction, and optimize machine learning model. So it is very clear to all of us that this is the backbone of data analysis, because it is not possible to execute the data analysis on a single dimension way. We generally use the two-dimensional, three-dimensional, four-dimensional database. Even you can say, if we are taking a table that is two-dimensional, or if we are storing with reference to time, that it may be included as a third dimension. So this will create a cube, data cube. And for this type of linear algebra is very essential for perform the data analytics in the same manner. Now, calculus, role of calculus in data analytics. Some of the experts of mathematics from the field of calculuses, we know that there two themes are there. One is the differentiation and another is the integration. Calculus plays a crucial role in data analytics, particularly in understanding and optimizing various type of learning model. It provides the tools to analyze rate of changes, model relationship within the data set, and optimize algorithm. So differentiation optimize the function identifying train and model dynamics system to find the optimal parameter by minimizing the error function. This is known to all of mathematician. Gradient descent and optimization algorithm used to derivatives to iteratively update model parameters, improving the model accuracy. Thus, differentiation is a powerful tool for optimizing and fine-tuning analytical models. To calculate under curves, we use the integration. So this solve differential equation and model cumulative phenomena. To compute cumulative distribution functions, CDFs, are expected values in time series analysis. Integration integrals helps to enhance the analytical capabilities of data analytics. So we can say differentiation basically concerned with the first and second type of data analytics, and integration helps or supports to the third and fourth type of data analytics, in which how can we achieve, how can we optimize, what will be the series outcome that may be introduced with the help of integral calculus. Then regression analysis in data analytics. Mathematicians generally use regression techniques. This is the statistical method used to understand the relationship between variables. Generally, we use the linear regression and multiple regression analysis. The most basic form of the regression model, the relationship between a dependent variable and a single independent variable using a linear equation. While multiple regression analysis extend simple linear regression by modeling the relationship between a dependent variable and multiple independent variable. So in a general way, we can say simple linear regression helps in the prediction the value of the dependent variable based on the independent variable. Curve fitting is the simplest example. By fitting a line to the data points, analysts can identify trends and make prediction. The goodness of fit measured by the R squared value indicates how well the model explains the variability in the data. Multiple regression is used to control the variables, identify the most significant predictors, and make more accurate predictions by including multiple independent variables. The model captures the complexity of real-world phenomena, offering deeper insight and more reliable forecast. One example for regression method is this: you can use the Mintep software, the tools which is available for this, or using the Mintep, you can identify, you can generate the function, and you can identify what is the missing value. And using the regression method, if a value is missing from the line curve, then you can predict or identify what is the significant role of that particular value. Time series analysis in data analytics. Another domain of mathematics is time series analysis. So many researchers are performing the work on time series analysis for various themes. Time series analysis focuses on analyzing data point collected or recorded at a specific time interval. By employing these techniques, data analysts can make accurate prediction and inform decision-making process. The main component of a time series are trained, seasonality, and noise. Trained represent the long-term movement in data, indicated an overall increase, incremental or decremental over the time. Seasonality refers the regular repeating patterns on a cyclic manner, or monthly, quarterly, yearly, or on the basis of season. And noise as the random variations represent the irregular or unpredictable malfunction in the data. Understanding these components is crucial for modeling and forecasting time series. So this is the very important theme. Seasonal time series analysis helpful for agriculture also, and several methods are used in the time series analysis to model and forecast data. For ARIMA, autoregressive integrated moving average, is a popular method that combines auto-regression, differencing, and moving average to capture the dynamics of a time series. Seasonal decomposition of time series, STL, they separate the data into trained, seasonality, and noise component, providing a clear understanding of each component contribution. These two are the very important themes for researchers who wants to perform the research in the field of data analytics with the help of mathematics, or one mathematician who wants to perform the research in data analytics. These two themes are very important. They perform the research and execution for the different fields. They may perform the research in the field of agriculture, in the hospital, diseases forecasting, and etc. Exponential smoothing methods such as halt winters are used to forecasting by applying weighted average to past observation. These methods are particularly useful for capturing seasonality and trends in the data. So time series analysis basically is concerned using the previous pattern at what the solution of such type of questions. So this is very important themes, time series analysis in the field of data analytics. Optimization in data analytics. Very important theme of mathematics, that is optimization. This is a critical aspect of data analysis, focused on finding the best solution from a set of feasible options. Or you can say, using the probability theory, you are generating the various aspects, and which one is most suitable, or which one is most reliable, or which one is most useful, we can optimize for more than two variables. So the availability of one and availability of two in the same manner may be executed. The simplex algorithm is a widely used technique for solving linear programming problem efficiently. Non-linear optimization deals with optimizing objective functions that are not linear. It is well known to all of us what is linear and what is non-linear functions, such as gradient descent, Newton's method, genetic algorithms are used for solving non-linear optimization problem. These methods iteratively search for the optimal solution, adjusting variables to minimize or maximize the objective function. So linear programming is applied in various fields such as logistic, finance, operation research. It helps in resource allocation, production scheduling, and portfolio optimization. By formulating and solving linear programming problems, analysts can identify optimal solution. And non-linear optimization is used in machine learning and various field of engineering. It helps in training neural network, estimation model parameters, and designing complex system. It enables analysts to solve challenging problems, improving the accuracy and performance of analytical model. So optimization is a very important field of mathematics in the domain of data analytics, because if we want to make the balance in two variables, the variables from the one field and variable from the another field or another domain, so there is a need of creation of balancing between two themes. Optimization techniques of mathematics are utilized. So this is plays an important role. Optimization techniques of mathematics plays an important role in data analytics. This type of data analytics may for the agriculture and different type of things. Graph theory in data analytics. Graph theory is the study of graphs, tree graph structures of mathematics. These are very important themes or plays an important role for the data analytics. Graph theory is the study of graphs, mathematical structure used to model pairwise relationship between object. A graph consists of, it's very known to all of us, this is a combination of a node and edges. Graph can be directed or undirected, weighted or unweighted, representing various type of network. So graph create the connections of two themes, of two domains, of two objects, or different type of domain connection may be established. Basic concept in the graph theory include degree, path, cycle, and connectivity. The degree of the vertex, mathematician is very much familiar. The number of edges connected, that is the degree of vertex. A path is a sequence of vertices connected by the edges, while a cycle is a path that start and at the same vertex. So these type of connectivity generally utilized in the network analysis. So data analytics of network synthesis for network processing, they use the studying the structure and dynamics of network using graph theory concept. They perform it very well. Techniques such as centrally measures, community detection, and network visualization are used to analyze network. Centrally measure like degree centrally, betweenness centrally, closeness centrally, identify the most important node in the network. Community detection algorithms such as modularity, optimization, and spectral clustering identify group of nodes that are more densely connected to each other than to rest of the network, that may be also identified with the help of graph theory. So this type of network visualization technique help in the representing the network structure graphically, or you can say you can represent the data set connectivity in a graph manner. It may represent the social network, it may represent the biological network, it may represent the transportation network. Transportation problem is another problem, another very important themes of the mathematics work. One of the most important conceptual themes of the transportation. The graph theory, game theory, these may be analyzed in the data analytics, providing valuable insight into the connectivity and behavior of the complex system. So in the using this graph theory, complex structure may be represent in the represent on the paper and as well as in the way of representation. Different type of SWOT analysis may also execute with the help of mathematics domain. Before starting the theme, different some more fields of mathematics, set theory, that is also represent the mathematical model of the computer science. Discrete mathematics, I have taken on into consideration just these field which are not very much familiar with the in the field of data analytics, because discrete mathematics is very popular themes in data analytics. Set theory is very important themes of the data analytics. So I think this moment it is slightly clear to all of us ki what are the role of different domain of mathematics in data analytics. It's in how statistical mathematics plays role, what is the role of probability theory, what is the role of regression technique, what is the role of differential integral calculation, what is the role of linear algebra, non-linear algebra, graph theory. So I think this should be clear to all of us ki in what way these type of domain of mathematics plays an important role in the field of data analytics, and different type of themes may be utilized for this. Another theme is that is the data cleaning and pre-processing. Data is available in the different form. Then make it usable, that is the another thing. Data cleaning is a crucial step in the data analysis process involving the detection and correction of error, inconsistencies, and missing value in the data set. Clean data is essential for accurate analysis and reliable result. With proper data cleaning, the data analysis can be misleading, leading to incorrect conclusion or poor decision making. So data cleaning is concerned ki which data is not in the desired format, then we have to convert, that is pre-processing. If that is not that is available in the different way, that it should be removed from the in existing data sets. The common data cleaning tasks include handling missing value. Handling missing value is concerned, for example, in a table, that table is simple concerned with the name, roll number, gender, etc. If gender is missing, on the basis of name, the attribute value or value for this gender value may be identified. So missing value, if there is missing, then it can be identified with the help of this stuff. Removing duplicates. If any data is exists in multiple themes, then one may be removed. Correcting errors. For example, if data exists, for example, if roll number is missing, then you can generate the roll number. If this is from this institute, then some field is this, or if that is only five digits are there, then we have to correct. For example, if we are taking into consideration 7 digit for a roll number and there exists 5 digits, then we have to correct the errors. And standardizing the format, that is by ensuring data quality, analysts can improve the accuracy and validity of their models, leading to more robust and basic themes is this: handling missing value, removing duplicates, correcting the errors, and standardizing the format. सेम फॉर्मेट में हमारे जैसे नाम हम किसी एक फॉर्मेट में लिख रहे हैं, if we are writing if literals, then literals should be as per norms and as per decided structure. Various techniques are exist for data cleaning and pre-processing. Data cleaning, depending on the nature and complexity of the data set, or handling missing value techniques such as imputation, deletion, and interpolation are commonly used. Interpolation, mathematical terms, that is very well known to all of us. So this is one of the very important technique, interpolate the data. If that is missing, that with the help of the mathematics interpolation, we identify it will tends where. Imputation involves filling in the missing value with estimated value such as the mean or median. Deletion, remove row or column with missing value, while interpolate estimate missing value based on the surrounding data points. Duplicate removal involves identifying and eliminating redundant records, ensuring that each data point is unique. This is uniqueness to maintain the asset property, atomicity, controllability, isolation, and durability. This is a very important theme. Error correction involves detecting and fixing inaccuracy. Error correction and detection technique fix the inaccuracy such as typo or incorrect entries. Standardization involved converting data into consistent format, making it easier to analyze and compare. By applying these techniques, analysts can enhance the quality and reliability of their data set. It is very much clear, it should be very much clear to all of us, if data is not in the desired format, that will generate the noise for in the at the time of processing. So before starting the exact processing, there is a need of pre-processing so that exact required data may be input for the existing system. So mathematics, with the help of mathematics play important role for data pre-processing, because this identify with the help of curve fitting, with the help of interpolation, with the help of different mean, median, mode, standard deviation, we can identify which data is truly reliable, or which data is uh, as it is in the form in which that may be processed. So these two themes, data cleaning and pre-processing, is very important in data analytics, and mathematics plays very important role in the pre-processing of the data, like in the form of different type of techniques. Up to this moment, it is clear what is data analytics or data analysis, data analytics, types of data analytics, role of different subdomain or different field of mathematics in the data analytics. But now there is a need to understand role of data science team, where what type of personnel, what type of persons are required or requested in the core team. Data analyst consist database administrator, data architect, data engineer, business analyst, data scientist that use the mathematics, design new algorithm, and these data analysts, data modeling, analysis, statistics, machine learning, visualization, and different type of business insight. It's mean they are all data architect, design and implement the storage solution and models. What are the tools are required, they designed with the help of DB and data architect design for the data analysis. This is plays an important in this is another role of this. So different roles exist in the data science team. In with the help of this architecture, we can identify one person who is mathematician as well as data administration, that may play the role of DBA as well as data sciences in the domain of data analyst. Some ethical consideration in data analytics with the help of mathematics. One is the data privacy. These are ethical consideration is essential to understand, because if data privacy is not there, then the mathematics which perform the operation of the existing data set, if that is logged data, then it may provide the different type of result. So what type of data with what type of consideration have to be provided for the mathematician, that is very important. And unbiasedness and fairness is essential for this thing. And in what way we are using that data, it is very important, so that wrong impact in the social domain may be minimized. Any social impact of the used data is in a positive way, not in the negative way. The data transportation should be transparent, and data manipulation is transparent, data recovery is transparent, and utilization should also be transparent. It's mean transparency is concerned in what way that is available for the execution, that should be known for the upper domain of the managerial. Who is accountable for this type of data? It is very important. If no one is accountable to for a particular data, then the result may not be reliable. So accountability is very important. The mathematician who is providing the result with the help of mathematical operation, he is accountable. The result is function is performed absolutely in correct way. Then consent and security should be there. If that mathematician is providing the data the, for from a domain, the domain consent, the domain may be personal, domain may be the informational, domain may be object sustainable, then consent should be there, and there is a intellectual property IPR should be there, and speed and security in transaction, these is very important. So suppose for example I have given a mathematical function to a mathematician, perform the function and execute, provide the result, and result is required at a particular moment, and mathematician provide that particular result after that moment. So optimization is not there, and result is not useful for the further utilization. It's mean real-time result from the mathematician should be provided in a secure manner in between the transaction. This should not be leaked, or this should not be utilized by another. For example, in the transaction manner, another function may be performed on a data set, then the result will be disturbed. For example, we can take, if we are performing g is equal to 9.8 is value, and for example we are performing the 10x is the function, and in between the transformation another square function may be incorporated within this model, then the result is not considerable. And if the result is provided after the execution, then there is no use. Real-time system is real-time consideration is very essential. Real-time consideration is very essential for this domain. Satellite data, real-time consideration, that is used the real-time consideration, and online is consideration is different thing, but real-time consideration very essential for mathematician in the field of data analytics. Future trends in mathematics and data analytics. The future of mathematics and data analysis is shaped by emerging technology that enhance analytical capabilities and enable new applications. AI and ML, machine learning, continue to advance, providing more powerful tools for data analytics. Techniques such as deep learning and reinforcement learning are pushing the boundaries of what is possible, enabling more accurate predictions and sophisticated models. Quantum computing is another emerging technology that is totally based on the mathematics, with the potential of revolutionizing the data analysis. By leveraging the principles of quantum mechanics, quantum computer can solve complex problems exponentially faster than classical computers. This opens up new possibility for analyzing massive data sets by tackling previously very slow problem. So different emerging technologies trends to data analytics are big data, cybersecurity, mobility, cloud computing, Internet of Things, social media. These are the emerging trend technology of data to data analytics. Future trends in mathematics and data analytics. The future of data analytics is characterized by increasing automation, integration and collaboration. Automation tools and platforms are streamlining the data analysis process, from data cleaning and data pre-processing to model development and deployment. This allows analysts to focus on higher level tasks and strategic decision making. Integration of data from diverse sources such as IoT devices, social medias, and genetic data is providing richer and more comprehensive data set. This enhances the ability to uncover insight and make informative decisions. Collaboration across discipline and industries is forecasting innovation and driving new application of data analysis. The future promises existing developments with mathematics and data analysts at the forefront is solving complex problems and driving progresses. In future trends, in general way, multi-domain, multi-dimensional, or multi-disciplinary data sets will be in future. Then there is a need to multidisciplinary type of exercise, multidisciplinary types of researches in future. For example, deep learning is there, genetic algorithms are there, GPT is there. So these type of future trends, these are the future trends which may be which are required to incorporate with the help of mathematics. So what this is a very simple steps. If we are initiating, then radiate, align, optimize, automate, transform, and improve. This is the simple flow of to achieve the maturity level for our data analytics prototype. In the first time we are taking into consideration prototype, we have to develop a prototype. So first in these themes, just crawling, this is just as a walking, and then we have to start fast movement from achieving this type of, then you will get the improvement, and this is the final stage of the maturity level of these are the strategic value for this. So at the last, importance of mathematics in data analytics. Mathematics ensure that data analytics is systematic, accurate, and reliable. For instance, statistical techniques help in summarizing data and making inferences, while calculus and linear algebra provide the foundation for understanding complex relationships within the data. Moreover, the importance of mathematics in data analysis extend to various domains such as finance, agriculture, healthcare, engineering, and social science. In finance, mathematical models helps in risk assessment and portfolio optimization. In agriculture and healthcare, data analysis aids in predicting diseases, outbreaks, and optimizing treatment plans. Thus, the role of mathematics in data analysis is both broad and deep, impacting numerous aspects of our lives. As a conclusion, we can say mathematics is the pillar on which society of data analytics is standing. The sources for this presentation are these are the sources from we have taken various themes from. Thanks for your kind attention. And rest of the slides are very specifically considered for the research purpose. For example, this is deployment of improvement roadmap. I will share this contents to all the concerned person. Some example of taking into task, how can we do the task analysis? How can we do project progress report? How can we create this type of report? How can we timeline monthly view? Can we get timeline quarterly view? How can we create this type of analytics? How can we do project risk analysis? Some type of example are presented, but because of the limitation of time, it is very difficult to discuss on all these themes. How mathematics plays an important, these all are KPIs dashboard. This is just because with the help of mathematics only analytics may be done. Cost resistance benefit matrix we can create with the help of mathematics, and matrix manipulation are very simple in mathematics. These are the perfect example of data analytics. And a prioritization matrix we can generate for impact. These all are the data analytics matrices or metrics of mathematic domain. We have taken into consideration different domain, different data field of design. These are the prototype maturity assessment scoring. These analytics may be done This is also another example of mathematic domain for this. These another example of checklist, how we can generate the checklist with the help, and we can analytics, perform the analytics. Survey, closer survey can be performed. Social media customer decision journey, we can execute this type of analytics, may be done with the help of mathematics. So there are different, so many roles on which we can perform. So these are the simple general discussion with reference to role of mathematics in the field of data analytics. So further, if you have any queries or want to make a discussion, so I am here to make a discussion. You can share.
Thank you so much, sir. That was very insightful lecture on your part. I would now like the audience, if they have any questions, queries, or would like to discuss something with sir, please unmute yourself and you can speak to sir directly.
Yeah, a very good afternoon to all. Good afternoon, sir. So your lecture and so live session is it's very nice. And so the topic of data analytics. It's my audible, ma'am.
Yes, you are audible. Please go ahead.
So in data analytics, so what is the role of Max? Sir, so in software predict also in unrealistic data. So how to use in mathematics to help verify this type of results? Sir? For example, in agriculture domain, the yield data is there, pest and disease data is there. So all the unrealistic data, so software, the lot of software is available in this global. So the software print that result. So how to mathematics or statistics help to verify that result, sir?
Okay, one simplest tools in is Mintab. Mintab, that we all knows the Excel sheet. Generally we produce the contents in Excel sheet, but there is a limitation. We can not generate a function, but with the help of Mintab, you can generate the function with related to attribute A, B, C, D, and E. F may be represent in terms of A, B, C, 2.6 A plus something, etc. So this type using, just because of testing domain, we generate a simple function, and after providing the various value in this function, we can predict the various behavior maybe execute in the future. Or overall, with the existing domain, we can generate a function, and remaining value may be put on this function, and we can generate the set of value, all possible set of value. This is the simple one, is the example. Another is the example is the Mathematica. Mathematica is also provide. Statistica is there. DB minor, database minor is another thing, and the SPSS is another. So many tools are available. On the basis of, we can perform the whatever you are saying, that can be performed, and we can find out the best optimized solution for these two type of domain. I think is this, and this should be clear.
Yes, sir. But so what is the difference in simulated prediction and mathematical prediction?
Okay. You are asking a simulator prediction is provide mathematical prediction is take the large set of data set, and simulator prediction is generate the function. Simulator prediction is generate for the making or generation of function. Simulation, in the simulation, we can put the behavior of the component and generate a model. That
so
model
generate result. So software produce the generated result. Yes, sir.
Okay. That is generative result.
Yeah.
Okay.
Okay, sir. Thank you.
Okay. Anything else?
Anybody else? Thank you, sir. I think that is all we have for now. Thank you so much for accepting our invitation.
Okay. Thank you, Namaskar. Thanks to all.
I would like to go ahead and offer a formal word of thanks to you On behalf of the organizing team, I extend my heartfelt gratitude to you, sir, for your highly informative and thought-provoking lecture. Your insights into the role of mathematics and data analysis have indeed broadened our understanding of the subject. Thank you so much for your time and contribution, sir.
Thanks to all.
Now, moving ahead with the program for today, our second session is and will be headed by Dr. S.B. Singh, sir, Professor and Head, Department of Mathematics, Statistics, and Computer Science. Sir, are you here with us?
Yes, I am here.
Sir, your video is stuck.
Am I audible?
सर की तरफ से प्रॉब्लम है
Video is stuck?
Sir, yes, you. Welcome, sir. Welcome to our platform.
Okay, thank you very much.
I would like to take a moment to
Thank you very
introduce
much.
you formally. Dr. S.B. Singh, sir, Professor and Head, Department of Mathematics, Statistics, and Computer Science, G.B. Pant University of Agriculture, Science and Technology, Pantnagar, Uttarakhand. Dr. Singh completed his PhD in mathematics from CCS University, Meerut. With career spanning more than 28 years, he has made remarkable contributions to teaching and research, publishing over 200 research articles. His session today is on the topic role of mathematics in agriculture. Sir, we are delighted to welcome you here. I now invite you to begin your lecture.
Okay. Okay, thank you very much for giving me the opportunity. Am I audible?
Sir,
Am I audible?
Sir, yes, sir, you are audible. Sir, can you please make your screen larger? Full screen or slide share? Yes, sir. That.
Is it okay?
Yes, sir.
Okay. Yeah. See, I have already introduced. Thank you very much for introducing, and I would like to thank the organizing team for giving me the opportunity to talk in front of you all. Okay. See, because we have gone through the very data analytics and everything, hardcore. Not much mathematics, but statistics. A lot of statistics is there. Now I'll be starting my lecture what we have studied in class 9th, 8th, and 10th. Okay, I will not be talking much about the mathematics, but where the mathematics or how what are the roles of the mathematics and where we can apply the mathematics. I'll be talking about that in the yes. Mathematician always feel proud that the mathematics is said to be the queen of. My voice is clear.
Yes, sir, you are audible.
Am I audible? Yeah.
Yes,
Okay,
sir. It's
yes,
perfectly
mathematics
clear.
is considered to. Yeah. Let me. A queen of science. That's why mathematicians feel very proud of all this because whatever happens in the universe, okay, directly or indirectly, it is related with the mathematics. Even the biologies are related with the mathematics. But yeah, today's talk will be focused on how mathematics can be employed or what are the roles of the mathematics there in the agriculture. See, agriculture itself can be divided into several components. Agriculture, then agriculture engineering, and then agricultural also there are storage and many different components are there. See, agriculture itself is a very complex thing. It's easier to say agriculture, but if we classify the agriculture, then we will be having several different components. See, now what are the roles? Okay, everybody could have studied this. Everybody could have gone through this one maybe in the class 7th, 8th, 9th. Okay, see conversion of units. What happens in the real life? See, the small farmers or the big farmers in the different part of our country itself. You talk about the acre, then the acre is having a perfect unit, and it's a perfect unit and have the universally accepted land. But see, if you go for the Biga and Bisas, then the different part of the countries used to have the different Bisas in the Biga, and the Biga is then converted into acres. Okay. Now, if you want to have the uniformity, then you can convert all those different type of measurement with the universally accepted. Okay, this can very easily be done with the help of mathematics. Okay, see now. Secondly, one is the conversion, and second one is the, if you have got the lands in acres or hectares which are universally accepted, but if you wish to talk in terms of the some local language where they are not accepting all this, then the vice versa conversion can also be done with the help of mathematics. Everybody knows this one, okay? And how one is the conversion of unit, and second we can use the proportions and the ratios also. Okay, everybody has studied in class 9th and 10th, all of you. I think everybody joined this workshop are mathematicians, or they are from the different fields?
Sir, we have participants from across coming from different fields.
Not all of them are not, all of the participants are not from mathematics?
No, sir.
Okay. Let me then. Okay, change my. Okay, I was of the view that everybody is a mathematician. No. Okay. Anyway, even if you are not mathematician, but you could have studied this. Okay. See how to convert and how conversion can be taken into consideration while going forward. Yeah. See shapes and size of the plots. See in the farmlands, the always shapes and size don't used to have the same yeah, or uniform pattern. Many times it is very zigzag, and many complex situation is there, and you could have seen that the several fights and everything are going on there in the villages, keeping in mind the plots and other things people are having. Even in the family, we used to have several fights corresponding to those plots. Okay, now see, of course mathematics can be taken into consideration, mathematics can help, but everybody is not familiar with the mathematics. Okay, if you wish to measure the crop, if you wish to see how much crop is to be grown where, okay, depending upon the situation, depending upon the weather dependence and agriculture, and
Excuse
when
me,
you
sir.
are not, yeah,
Sorry to interrupt, but all that we can see is your first slide. Your slides are not moving.
not moving
No, sir. I would like to
now.
confirm. No, sir, they are not moving. We can just see your introductory slide.
Okay, now
No, sir. Now you're not sharing the screen.
should I go back?
Yes, sir. That might help.
What about now?
No, sir.
No. Oh.
You're not. You're currently not sharing the slides with us.
Yes, let me share once again. Is it?
Yes, sir.
I think there is some problem with the sharing. Let me continue in this way.
So we are on the fourth slide with you, conversion of units for measurement.
Yeah. This is what I was talking earlier. Okay. Yeah. Next is the shapes and size of the plot. Is it now clear?
Uh, yes, sir. It's
Yeah.
moving now, sir.
Okay.
All
Yeah.
right,
Well,
sir.
let me
Continue.
continue this way because yeah. See, the shapes and size, because as I said, the shapes and size not always used to have the uniformity. Okay, how to deal with those situations, we have to take the mathematics. Okay, and secondly, depending upon the shapes and size of the plots, we may have different type of means the outputs may be different. How to deal with all this one, how to estimate all this, we have to take mathematics into the considerations. Okay, see, many times the traditionally what people used to do is they used to count the number of heads, or farmers can calculate with the help of, on the basis of what is visible to them. and many times they don't take into consideration mathematics, but that is not going to give the right picture. Of course, mathematical modeling can help in doing all the things. Of course, you have to have all the parameters before modeling the situation. Yeah, see, calculating a profits and loss. All of you are aware of this one. See, profits and loss, everybody, I think, whether the people are from mathematical background or from engineering background or maybe from the biological background, they could have studied this in the schools, calculating the profits and losses. Okay, but here, if we go for the slightly go into the deep, then see, problem is it's not simple about the profit and loss, because if something, sometimes suppose you say that I've invested this much, I have earned this much, then you can say that this is the profit or this is loss. But in between, how to earn those profit and loss, for that you may have to plan. Okay, how that can be done? Say, for example, what are the timings, where to crop, when to crop, how much to invest, what should we avoid, and what should we not. Okay, all this can be done before going for the profit. No, you can plan by doing all the things. Okay, see, profit and loss is the last outcome, but in between, several plannings are required, and those plannings can be done with the help of mathematics. Okay, see, and it's not about the this profit and loss. And then if you plan in advance, if you plan everything, if you set your parameters in the right way, depending upon the situation, depending upon the historical data and other things, you can earn profit and loss in a better way. See, next is the, see, to calculate the loss and profit is not a typical thing. What is slightly problematic is that, say, if you are thinking about uh, profit and loss, everybody is planning for the profit, nobody is planning for the loss, but the loss may incur. The question is how to minimize the loss and how to maximize the profit. Okay, there are two things. The maximization of profit not always help in minimizing the loss, or the minimizing loss, because sometimes situation turns in such a way, due to weather or any other thing, then the things go in the wrong way. So to deal all this, we have to go or take into consideration the mathematics. Yeah. Next is the soil analysis. See, now government of India is providing the soil cards to the farmers. Soil analysis is very very important, and more often farmers could not take this in account before going for that, because they have their own mindset. Go for the urea, or go for there are certain fertilizers, there are certain insecticides. They used to take the help of all those. They don't plan, and they don't see whether my soil require that or not. See, for that, what we can do, go for the soil analysis. Soil analysis will help you in checking that what are the nutrients available in the soil, what are the nutrients not available in the soil. Okay, depending upon all these, and if it is available, to what extent it is available. See what farmers are doing without taking into consideration whether the nutrients are available. Number one. Number two, to what extent it is available, they used to go for the same fertilizer, irrespective of the soil. And sometimes even if it is not required, and then this is harming the land, this is harming the means harming the environment, and many more things are going on depending upon that. Okay, see, second is of course you have to take the help of mathematics. Okay, and during the analysis of the soil, and analysis of the soil is not so straight way. And I am not saying that this is a rocket science as well. To analyze the soil, there are several things you have to take into consideration. For example, the moisture content, for example, the acidity, and other things, and depending upon that, you have to plan that which this soil is, whether the soil is will be supportive to a particular type of crop or not. Okay, see, in different parts of the country, people are going for the different crops, and many times it is being said, it is being seen nowadays that the soil, whatever the soil available in a particular place, are more helpful for some different type of crops rather than the crop they are going for several years. Okay, and that way the farmers are earning a lot. Okay, it means the soil analysis is a very, very important component, and of course you can do this with the help of mathematics. Okay, similarly, while going for the analysis, of course, you have to take the numerical analysis or the numerical techniques helps. Okay, whatever comes means during the analysis. Then you may take the help of the numerical techniques, and now the help of the numerical techniques, you may estimate, okay, what amount of the fertilizer is required and what will be the cost, and how to obtain the maximum production. Okay, see now, see, in the realistic situation, or more often in our country, they don't go for the soil analysis, and the soil analysis is one of the, see, before going for the, before going for the crop, you may plan in advance whether it is supportive or not, and depending upon that, and depending upon all this, you may plan, and depending upon all this, you can check whether should I go for that one. If I go for that one, what should be the input? What are the inputs? And what are the what will be the extents of that input? And keeping in mind all those, then you may plan accordingly, and then of course you can maximize the production. And if you are maximizing the production, there is a chance that you may maximize your profit as well. And then second important thing is soil analysis. With the help of soil analysis, you can better plan how the crops should be rotated in order to maintain the fertility of the soil. You just see that many parts of the country, the level of the soil is getting very, very poor, and rather not poor, but they are means, what should I say? Many different kinds of diseases are being faced by the different part of the country due to this wrong, or the high use of the fertilizers and other things. See, now the next is the grading of seeds. See, the grading of seeds, this is very common thing. You can see that depending upon the grades and the number of which grade seeds should I use. Okay, and this grading is usually done on the basis of the, and is usually helpful in shapes and size of the grains. Okay, see, now if you are going for the, if you are planning, then you can in advance check that the which number is more suitable, and these all can be done. Okay, grade one first thing is that gradings are done with the help of mathematics, uh, of course agriculture scientists are there, but the gradings are ultimately done on the basis of the mathematics. And then once you have got the what should be the number, or which should be the grade should I use, and depending upon that you may plan. Okay, and once you have right choice, then it will be better for you, because in the right choice is there, then the depending upon that, depending upon the demand, nature of soil available, effective cost, and the climatic conditions of the area, you may plan which number of seed is more suitable for the particular land, or whatever the land you are going to use. Yes, next is the marketing. See, marketing is not all about mathematics, but a lot of mathematics involved in the marketing. See, when we are going for the marketing, then of course it involves the transportation, storage, processing, and packaging. See, transportation involves a lot of cost. Question is that during the transportation, which route is to be selected, and many of the participants could have studied the operations research, and in the operations research, transportation problem is one one of the very important chapters rather, where transportation, how to plan the transportation so that the transportation cost is minimized. Then the storage. In the operation research also, those who have studied this operation research, the inventory problem. Inventory problem is itself is a very challenging issue, and the storage basically, storage is the one of the important, rather not one of the most important component, that is inventory control. Of course, processing, packaging. In the packaging, when you are going for the packaging, then also you have to see that the what should be the quality of the packaging, and to what extent we can package so that the whatever the packet is there, that may tolerate the weight of the whatever we are going to process. Okay, you can see that the transport, whether it is transportation problem or the inventory problem or the processing or packaging, the mathematics is involved. Okay, and next is the demand and supply. Demand, where it is in demand, or what is the demand, number one, and how to supply. And then while going for the demand and supply, you have to choose that what is the transportation cost, and transportation cost, all this can be minimized, profit can be maximized with the help of linear programming techniques. Okay, of course, these all techniques comes there in the operations research. Next is the geometry. Okay, when we go for the geometry, I mean shapes and size of the storehouses or whatever the warehouses are there. See, while going for the warehouses, while planning for the warehouses, geometry is one of the important thing. On the basis of the geometry, you may plan and you may design your storehouses or warehouses or wherever you are storing. Okay, of course, there again mathematics. See, the mathematical modeling can be performed for the, of course, for the problem, transportation problem or the inventory problem. I mean the storage problem. For all the mathematics modeling can be done, and mathematical modelings are always already there. You may use those modeling, or you may mathematically model depending upon your own inputs. Okay, and then once you have done all these things, you can plan a better way. You can go for the better way of marketing. Next, estimating of the crop yield. See, it seems that the crop yield is simply whatever inputs are there, accordingly you'll be having the output or the yields. But it's not like that. Not exactly like that. I mean, see, what are the inputs and how to minimize the inputs, how to minimize, or what way should we use the input so that our yield is maximized. See, when you are thinking about the maximization of yield, then there it's not that only if you are going for the large amount of fertilizers, then yield will be good. Of course, there may be chance that the yield may be high, but at the same time, there are several negative issues are attached with that one. Health issues are there when you are going for the higher chemicals, higher fertilizers. Okay. Now, how to do this one? To maximize the profit, and for planning all the things, you may take the help of linear programming. In the linear programming, one is assignment problem. See, while suppose a particular farmer is, or particular big farmer is having a very large farmland. In that farmland, then he may be having the mecha- uh, mechanical instruments. He may be having the labors, skilled labors, and many more things. Okay. Now, assignment problem. Again, the assignment problem is one of the very important chapters there in the operational research. So, how to assign different people or different machines, different tasks, so that the cost is minimized. And all these can be planned with the help of mathematics, of course, with the help of, specifically if I say, of course, with the help of assignment problem. Okay, and in this way you can minimize the cost. Okay, once the cost is minimized with proper planning, with the assignment problem or assignment problem techniques, then the you may improve or you may increase your profit. Okay, and then at the same time, if your planning is better, then you may reduce the working time and maximize the production. See, developing the climate models. See, climate modeling is a very, very challenging task. And nowadays, even after having what means nowadays, whatever the climate models are there, they are means very, very accurate in comparison to the last, in comparison to 10 years back or like that. Okay, and even after that, see the disasters we have seen within 10-15 days back in the rally in the Uttarakhand and the Jammu Kashmir, Kishtwar region. See, develop, it means the climate models, even after having such a accurate production, but the cloud busting is not, still we are not in a position to forecast that the cloud busting will be there. Okay, see, is it possible those who have joined here, those the youngsters joined here, or young professors joined here, or maybe from the different field, is it possible to model, go for the mathematical modeling so that the cloud bursting can also be predicted? Okay, you think about this one, and then maybe some of the people joined today, maybe doing some research work there in the climate model. Think about this one, because I don't think that this there is any model where we can accurately forecast about the cloud busting. Okay, anyway, come to the development of climate models. Okay, see, climate models are there. Okay, in the normal situation, very good climate models are there, and those modelings are, of course, done with the help of a plan. Such a way that the time is, the amount of the time is, or the proper time can be selected where when to go for the better way. See, if we are going for the, if we are not using all those things, okay, or see, there are two issues. One is the climate models where it is been planned in a normal way, and second is that nowadays many unpredictable changes are, we can see many unpredictable changes. The question is that how to model in such a way so that those unpredicted situations can also be incorporated. Of course, we can model keeping in mind those unpredicted situations, and then we may go for the simulation. Okay, there are or there we may go for that one. The question is that if we haven't seen all this, then we may have to go for the theoretical situation or hypothetical situation, that if this happens or that happens, then how the outcome will be. Okay, and this, it means, what I mean to say here is that in the normal situations, we the climate models are helping a lot. Okay, and the abnormal situations are not very common. Okay, it's not the everyday abnormal situations are there, but depending upon, or planning in such a way that if different situations are there which may be hypothetical, you may try to model, and then if any time those type of situation prevails, then the output may be forecasted. Okay, yeah, see, but in the normal situation you may go for the better, or better way if the climate models are there used in sowing, reaping, and the storage, and other things. See, next is the how the applications statistics are. See, statistics is not actually mathematics, but many times people used to say that those who are in mathematics they know statistics also. Okay, but it's not true. Okay, previously you have gone for the data analysis. See, data analytics is one of the burning topic nowadays, and the data analytics is being done by the engineers, by the statisticians, by the mathematicians, and many other people. Though the data analysis is specifically or in a hardcore way, it's a part of the statistics, but the other people are doing another doing very well as well. Okay. See, now the here, as far as the role of mathematics is concerned, of course, I have considered statistics also in mathematics now for today. See, while going for the different things means different aspects, and more often mathematics and statistics both play very important role. Rather, after whatever data is there, you have to go for the analysis. Without analysis, you cannot get the right picture, and that all can be done with the help of statistics. Say, for example, okay, if you are collecting. After the collection of data, you have to analyze, you have to interpret. Okay, see, if the agriculture scientists are also joined here, then the what I have observed sometimes that they used to do the very good thing. They used to have the very good data, but the problem is that their analysis is not proper, or their analysis is not up to mark, or they haven't done the analysis which are actually required for. Okay. Uh, Hence, even after having the very good data, they cannot have the good analysis, and they cannot have the right prediction for that one. That's why that analysis is very important. You have seen prior to this talk, you have gone for the data analytics, but for that you have to have the good knowledge of statistics, and of course, if you wish to have the good knowledge of statistics, you should have the good knowledge of at least a fair knowledge of mathematics also. Okay, see, data collection and the quantitative analysis, they are the two different parts of the two different parts of the analysis. Of course, if you don't have the data, you cannot go for the quantitative analysis. But important thing is that whether even after having the data, good data, are you going for the right analysis, or are you going for all those analysis that can be performed? Okay, this is it. This is not that much challenging, but uh, on the basis of my experience, what I'm saying is that many times those who are not from the mathematics background, they are not going for the right analysis. Right analysis means or the analysis which are actually required for. Yeah. So one may think about this one. How data analysis may be helpful? It may be helpful in estimating. It may be helpful in planning. It may be helpful in development of agriculture and national incomes. Okay. See all the things. See everything you see is ultimately based on the data analysis. Whatever data. Today, here I am talking about the agriculture, but it's not about agriculture only. Any data you think about, okay, ultimately analysis is required, and proper analysis can help. Okay, see, next phase is the in the analysis part. See, if you are having a data with the help of interpolation methods, numerical methods, or interpolation methods, or different interpolation methods like Newton forward, Newton backward, or Gauss, or Stirling, Bessels, and Hermite, Lagrange's, Newton divided difference. Many different interpolation methods are there. Choosing the right method, and you can interpolate. On the basis of the interpolation, you can forecast. Okay. I mean, you may interpolate, you may extrapolate. See, while going for the interpolation, see what we have to think about, or what are the outputs we may have. One is the weather forecast. If you are going for the forecast modeling corresponding to weather, if of course rainfall is one of the uh, comes under the weather forecast. Okay, and the different temperature variations. Okay, market economics and many more things. These are the very a few example I am just citing you. On the basis of data, you can extrapolate many of the things. Okay, see now second is the on the with the help of interpolation you can decide the time of sowing of the seeds and the harvesting also. Okay, these all can be scheduled with the help of analysis and of course with the help of application of statistics. See, the second task is in the agriculture engineering. See, agriculture engineering, the engineers used to have the. It's not only about the crop management. It's about the engineering instruments. And when you are thinking about the designing of the engineering instruments, you know, or you are thinking about the R&D of the engineering instruments, you have to take the help of mathematics. What should be the design, what should be the size, how what should be the angle, and what is the optimal angle, or many more things. Of course, all those can be decided on the basis of mathematical modeling. See, one is the agriculture, second is the agribusiness industries. In the agribusiness industries, agribusiness industries they purchase material from the farmers and then they go for the output. Different products are there. They are going for the different products. Okay, see how they can plan when to purchase, how to purchase, what route should be chosen, and that way they can minimize the inputs and they can go for the maximization of the profit. Okay, and other issue, one of the challenging issues nowadays talked about is the sustainability of the nature. See, and the renewable resources. Okay, see, it's not directly mathematics is involved in the sustainability and nature, but to analyze, to interpret, to examine sustainability and other things, we have to take the help of mathematics. See, next, predictive modeling and forecasting. Though I have talked about the modeling, see, predictive modeling. See, predictive modeling is very important modelings as far as agriculture or agriculture or farming is concerned. Okay, see, the predictive modeling is not only about how to predict. See, the important thing is when you are going for the predictive modeling, what are the inputs, what are the variables you have considered, whether you have considered all the variables or you have left some of the important variables, because there are in the predictive modeling there are some decision variables, and there are some variables which are controllable and there are some variables which are uncontrollable. While going for the predictive modeling, are you considering all those? Okay, what happens in the normal life when we are considering uh, many of the variables, then the modeling sometimes used to be complex. Then what people used to do, they used to leave some of the variables, and in doing so some of the important variables may be left, and after modeling with those important after leaving all those important variables, your modeling may not be that much good. Okay, whatever you are forecasting on the basis of modeling, that may not be good and that may not be accurate. Okay, hence while going for the modeling, you consider as much possible, as much variables which must be taken care of. Don't leave the important variables while going for the modeling only for the sake of simplicity or for the sake of easiness. Okay, now say crop yields are there, insects outbreaks are there, weather patterns are there, soil health and crop development, all these can be predicted. See, one thing, whatever the nutrients available in a soil today, the same amount of nutrients may not be available after 10 years, may not be. Now, then how to deal with this situation? it means while going for the predictive modeling, you may have to consider those things in the dynamic situation. Okay, more often we used to consider all those things in a static situation. That whatever the input that is being taken, that is being considered to be fixed, but uh, that may not be correct always. That may not always be correct. Sometimes may not, maybe. Okay, see, that's why predictive modeling and forecasting is very important, especially not especially there in the agricultural field. See, on the basis of the predictive modeling, you may decide, or you may decide, or you may go for the decisions, because once you have had a wrong decision, then the many cumulative negative things may happen. And if you are taken the right decision, then you may have the better situation. Okay, that's why predictive modeling is very important. And secondly, predictive modeling, all those modelings, while going for the analysis part, then you may take the care of statistical analysis and the machine learning. Machine learning is widely applied nowadays, and here also you can go for use the machine learning. And in the background of the machine learning, mathematics is involved. Okay, and the predictive, once you have got the good predictive models, then you can forecast the future crop yields. Okay, by examining the past yield data. Okay, not only on the basis of your own data, but if you are having the 10-15 years data, depending upon that, you can forecast the what can be the yield, what will be the weather pattern, and the soil properties. All those analysis can be done properly. Next is the how to maximize the profit or the productivity. Okay, see, by allocating the right resources. The question is that how to decide the right resources. Of course, also with the help of the analysis. If you had the analysis, then on the basis of the analysis, you can have the outputs. Once outputs are there, then you can see what are the outputs you have got for the different situations. On the basis of those outputs, you may go for the right allocations. On the right, you may go for the allocations of the resources in a proper way. Okay. Other thing is the decision-based controls. Okay, you see, nowadays insecticides and the pesticides are widely applied, and due to that applications, the people are facing the different type of problems, health issues. Okay, see, disease and pests can also be forecasted on the basis of the inputs. Okay, because if you have got the data, you have got the data on the last many years where the diseases were reported, or the then you can keeping in mind all those inputs, go for the modeling and decide the what are the chances of the outbreak of the some of the disease. Okay, see, this is what you can. Okay, next is the, if you have got all the predicted outbreaks, and along with that, if you integrate the historical data, meteorological circumstances, and the crop health markers. Okay, so see, now what is the situation? It may not be the case that everything you could have encountered, but if you integrate all those things with the help of different integrations, you can go for the different modeling, and on the basis of that, you can have the outcomes. And if sometime those type of situations, even if it is hypothetical, but sometime if the practically you are seeing those ones, then the proper model is there, then you can forecast that this is expected to happen. Okay, yeah, see, the crop damage again, if you have got the right predictive modeling, then you can forecast that the chances of crop damage is there. Okay, or you may forecast in the early detection, or you can forecast, or if you have forecast means the chances that you can early have the knowledge, then earlier the knowledge, then you can have the preventive, whatever the preventive management, you can perform all those things, and you can have the targeted insect treatment prior to that one on the basis of what you see. And if you have got the proper predictive models, then the farmers can minimize the risk associated with that one. See, ultimately, if some you have gone for some crop, but if it is suffering from the diseases, and you are going to lose a lot. But if the proper model is there, then it can be forecasted, and once it is forecasted, or even if the risk is being forecasted, you can go for the preventive situation, and then in that way you can reduce the damage if you cannot stop. Okay, same is the case of the soil fertility and health production. Depending upon the historical data, prevailing situations, you can go for that one. Okay, you can predict that today my soil is like this, or having this much moisture, this much content, this much nutrient. After 10 years, what will be the soil fertility levels? All this can be forecasted. Okay, and then what to see what happens. Okay, everybody may be familiar with this, that whenever the farmers are going for the application of fertilizers, they apply same amount of fertilizer everywhere, irrespective of the situation, that whether that is required at every place or not. Okay, sometime what happens, at some places in the same farm, that much fertilizer is not required, and sometimes it is required, but they don't go for that one. They don't plan. Okay, because they don't have the data, they don't have the actually this analysis. That's why they are going for that one. But they all can be planned. But which, where, and how much fertilizers or insecticides or the pesticides are to be employed. Okay, that all can be planned with the help of predictive modeling, and of course, this is going to help in the decision making. You can reduce the risk. You can use the resources in an optimal way. You can promote the farming for the pesticides in a better way, and then lastly, you will be having the efficient and sustainable planning. Yeah. Next is the precision algorithm. This is one of the important thing going on. Not much here in our country, but the precision agriculture is taking place in the there in the Western countries and the other parts of the developed part where the large lands are there. Okay, they are using the data driven methodology. Okay, keeping in mind all the data, then they try to integrate all those data and then try to maximize the. Okay, in doing this one, they use all the available technology, all the data analytics, and the comprehensive knowledge of regarding, and then integrate all this. Okay, normally when we go for the any model or modeling, then we go for the particular thing. We don't more often we don't consider integrate all the things. Okay, but in the precision agriculture, we may integrate all this, and on the basis of that one, the better um, forecasting situation may be there. Say, for example, when you include the crop health, soil condition, moisture levels, and other topics using sensors and GPS technology. Okay, see, nowadays the sensors and GPS technology, drones, and other technologies are being used. If we integrate on the basis of all this, then the outcome will be better. Okay, GPS and drones and other technologies. Okay, drones are being government is promoting a lot. Okay, drone this and like that you could have listen many times. Okay, and that's on the base with the help of this, of course, we may go for the better planning, and then this all comes under the precision agriculture. Okay, once you have it, once you use all this one, you will be having a you may go for the well informed decisions, and of course it is going to help in a better way in comparison to particular or modeling where you are going for the decision or taking the decision on the basis of some particular inputs. Yeah. See, GPS guided machinery and the soil moisture sensors. Okay. In the precision algorithm, when we are going for the more mechanical, they all are sensor based. And with the help of all those sensors, everything can be take everything. Rather, inputs are there. Okay, the exact inputs are there with the help of all those sensors, And then when you take all those inputs available on the basis of GPS guided machinery or with the help of the sensors, then you may better plan. Why? Because the best inputs are available to you, and whatever modelings are there, they are going to forecast, or they are going to give the better result. Okay. Similarly, with the help of this one, you can plan in a better way how to use the fertilizer, what amount to be used. This all can be done. Okay. And then, of course, because as I said earlier, over application is having the negative effects on the environment. Okay, but with the precision algorithm is there, because the sensors are there, they are giving you the accurate data, and in that way it will be a better situation. Means better situation, I mean that you may plan in a better way. See, optimization techniques, there are two things. One is the numerical techniques, other one is the optimization techniques. The numerical techniques are also used large in a very, because whenever you have got the data, and if you wish to integrate, you have to go for the numerical integration. Whenever you have got the data, if you want to forecast, you have to go for the interpolation. Similarly, as far as optimization is concerned, if you have got the all the inputs, see, what is the problem is that you may be having a particular objective, but the objective cannot be optimized with the help of whatever objective function you are having, because there may be several constraints related to weather, related to the cost, related to the budget, related to other things. Okay, environment conditions. Okay, on the basis of all those, you can go for the linear programming or maybe non-linear programming, and all this comes under the optimization technique. Okay, once you take the help of this optimization and plan in a better way, you can improve the productivity, efficiency, and the resource utilization will also be better. Okay, of course, for the optimization techniques, you have to go for the mathematical modeling first. Mathematical modeling, no, of course, you have to use the algorithms for that. Okay. See, effective crop rotation and the planning schedule can be done with the help of optimization models. Okay, if you have got everything, you have got the because in the optimization models, whatever the constraints you are keeping in mind, those constraints also, and on the basis of the constraints you are you are trying to optimize your whatever decision you are going to take, and hence in this way, once you have got all those, then you, it may be giving you a better opportunity or better thing, wherein effective crop rotation and planting schedule can be used. Okay. Similarly, managing irrigation. Okay. See, there are two tasks. One is the irrigations. Irrigation itself is a challenging one. How to irrigate there are two things. One is the irrigation, one other is the channels. There also in mathematics is involved, and then is the managing irrigation. Okay. See, and in the managing irrigation, see, water availability is not always the same. You see today Delhi, from the Hatnikund, how much is not being done always. See, to manage all these things, ultimately you have to go for the mathematical modeling. See, I'll be taking only 4 5 more minutes. See, genetic algorithms and AI. See, every time now people are talking about the AI, whether it is agriculture, not much in agriculture, but in the normal life we are talking much about the AIs and genetic algorithms. See, artificial intelligence and the GAs are widely applied, and they have revolutionized the agriculture. And I wish those who have joined, I wish that some of you may start doing research with the help of these genetic algorithms, AIs, and then a lot of scopes are there. A lot of scopes, and those people doing work here in this one, they are having very good research papers also. Okay? Hence, you may think about this also, depending upon your field. See, so once GAs are applied or AIs are applied, you may then you may simulate some of the participants. Probably Dr. Iswari was asking questions related to simulation in previously. Okay, you may simulate with the help of genetic algorithms. Okay, once genetic data and traits are there, you may plan in a better way. Okay, see, AI is there. Everybody knows AI is revolutionize the agriculture field also. uh, Hence, here you may think about the applications of the GA and agriculture. Okay, with the help of this AIs, you may forecast what are the resistance of the disease, increase yields, or environmental adaptability. Everything can be forecasted with the help of AIs, provided you are having the right inputs, okay, and the robotics and the machines. See, the robots are fitted with the different sensors, okay, because the sensors are ultimately doing their and using these robotics and the machines. Of course, in the background, mathematics is there. Okay, while going for the design and other things, mathematics is there. In the machine learning, mathematics is there. When you take all these things, whether drones or satellites or sensors, okay, this all will help you in a better planning, better management, and better way to go for the forecasting and other things as well. Okay, it's not only forecasting, and once it is rightly forecasted, then you may go for the early intervention. Early intervention is if something is forecasted that this is being expected, which may be negative, then you may try to intervene in such a way so that that can be reduced or minimized. Okay. Next is the automatic farming. These all are AI driven robotics, automatic farming. Okay, where the robots are doing all this, though it is not there in our country, but automated farming is going on in the developed country, and with the help of them, they are having the better situation. They are having the better outputs also. Okay, see, see, in the AI-driven technologies, see how they are going to help. They are going to help. See, whether you are going for the analysis or other things, they are going to help you. In the AI base, the outputs are slightly better. Okay, right, better. Hence, the predictive analytics and the disease detection and the robotics automation, genetic algorithms, this all are rather revolutionizing the present situation. Hence, uh, even if it is not being done here in our country, those who are interested may try to do the research work, keeping in mind all this. Okay, yes. And next is the decision support system. Decision support system is, though I have talked earlier, is a contemporary decision support system, instruments where ultimately one has to take the decision, and for taking the decision, what we have to do, we have to have the right knowledge. How the right knowledge can be had? The right knowledge one can be had with the help of with the help of either precision farming or with the help of the predictive models or other things. Once you have having those knowledge, then you may go for the better way. Okay, I'm skipping some of the portions this year, yeah, because of the sort time issues. Yes, network analysis for supply chain. See, the supply chain is other important component. Okay, networks are there. See, from farms to the output, from the farms to the export, from the farms to the destination. Say they all are connected with the help of different nodes. You may make a network, and with the help of network, you may go for the optimizations. Okay, and that can all be done. What are the nodes means different you may say destinations, and how to deal with those destinations, whether all those nodes are required for the maximization, or some of nodes are there to be minimized, keeping all those networks. A chain is there, supply chain is there. Okay, and With, of course, with the help of operation research techniques, you can go for the better supply chain or supply chain management. Okay, and then you can minimize the transit time. You may cut down the time of transportation cost and optimize the routes and many more things. So, because it's not a straight way from farm to export. It's not from farm to market. Okay, there are several more things, more nodes are there. Those in the network analysis, those are being said to be nodes. Okay, yeah. Lastly, stochastic modeling for the risk assessment. See, everything is not means deterministic. When we are going for the modeling, everything is not deterministic. Many times they are probabilistic, they are stochastic. Hence, the stochastic modeling is very important. See, if some uncertainty is there, either you go for the stochastic modeling, or you may go for the basis analysis, or you may go for the risk assessment. All this, while going for all this, you may think about the stochastic modeling. During the stochastic modeling, of course, probabilistic situation is there, and you may take into consideration those probabilistic situation or the uncertainty involved. Of course, stochastic modeling. The other aspect is the people are doing the work with the help of fuzzy also, and this is again going to help you a lot. Okay, the stochastic mode. See, I repeat, stochastic modeling is very important, because while going for the modeling, every time everything is not deterministic. They may be probabilistic. There may be some uncertainty. Those can be done with the help of stochastic modeling. These are the some of the references. Thank you very much. If you have if anyone has any query, please feel free to ask the questions.
Thank you so much, sir. On the behalf of all participants and organizing committee members, I extend our heartfelt gratitude to you, sir, for taking out valuable time from your busy schedule to deliver such an insightful lecture. Listening to it reminded us of our class days when we used to solve.
Echo is there. Some echo is there.
Okay, sir, just wait. Volume broken.
Any queries from sir? Participants?
Sir, is it okay, sir, now?
Yeah, fine.
Okay, sir. Sir, thank you for your insightful lecture. You focused on the applications of linear programming problems, transportation problems. We remember these were the problems we used to study in class while studying the operation research and other topics. At that time, we do not know these problems actually hold such a insightful applications in the field of agriculture, industry, and other fields of technology. You also discussed about the role of mathematical modeling in analyzing agriculture systems, in solving problems related to demand and supply, marketing, and resource allocations. Moreover, at last, you also talked about the optimizing logistic inventory models, which are very important in agriculture sector today. Once again, I would like to thank you from on the behalf of all participants and organizing committee members, sir. Now, the session is open for any kind of discussion and any questions from the audience, please.
Sir, you talk about, hello.
Yes. Please go
Sir, you
ahead.
talk about the use of operation research inventory problem. Sir,
Yeah.
can traveling salesman problem be used in agriculture modeling or supply chain management?
No. Yeah, traveling salesman problem. See, traveling salesman problem is nothing different. It is a part of assignment problem. Okay. In the is a particular case of assignment problem. Earlier, it was treated as a puzzle, traveling salesman problem. But the traveling salesman problem, see, say specific condition is prevailing, and under that situation we are doing. Say, for example, of course you can use because when you are going for the transportation, say you cannot transport from the same city to same city. Okay, and sometime what happens? See the sometime origins and destinations may be a destination may be origin, other destination may be origin. See, of course, all these are being used there in the transportation, but the traveling salesman problem, of course, it can be used there. Yeah.
चलो ठीक है आज भी टाइम पे
Okay, sir. Thank you so much, sir.
Okay, any other questions, please? Okay, thank you so much, sir, for your lecture and taking your time to deliver and addressing the FDP, sir.
Okay, thank you very much. Thank you very much for giving
Thank you
me
so
the
much.
opportunity to talk in front of you all. Okay, thank you very much, Savan, Dr. Savan, and Dr. Prerna, and other people who are directly or involved in this workshop, because you people have talked to me directly, and other people, of course, many people, not maybe, are involved here, and I would like to thank all the members, team members involved in this organization. Thank you very much once again.
Thank you so much, sir. Okay, this will be all for today. We'll continue again tomorrow on the third day of the FDP from 3 o'clock to 5 p.m. Thank you, everyone.